You are listening to Information Security and OSINT Podcast, Episode 50, originally released on March 25th, 2021. As always, I'm your host, Josh Amishav. Today we have Petkov, aka PDP, on the show to talk about PownJS and SecApps. PDP is the founder of GNU Citizen, the director of information security at Onfido, a frequent speaker at various industry events, and a prolific blogger. My three main takeaways from a conversation were 1. How to integrate PownJS as part of a bug bounty methodology, 2. His Recon workflow to learn about a target, and 3. Why JavaScript is a great language for quick POC development. You'll enjoy those 3 things plus a bunch of other tips along the way. Direct support for this podcast comes from BreachSense. If you need visibility into your clients, employees, or third-party suppliers' breach credentials before criminals exploit them, then head on over to breachsense.io to apply for a free 7-day trial. And now here's my conversation with PDP. PDP, welcome to the show.
Thanks for having me.
It's great to have you here. So you're involved in a whole bunch of projects: GNU Citizen, OpenDev SecOpps, Weird Rocketeer, WebSecurify. Can you tell us a bit about what those projects are and who you are?
Yeah, sure. So my name is Petkov. I go by the handle PDP Online or PDP Architect. I've been involved in the security industry for the last 16 years professionally, but I've been interested in security since a boy. Maybe I don't remember. Maybe I was 10 years old or something like this. And so all these projects essentially are the culmination of all the work that I've been doing. I've been taking different types of roles over the last 16 years, from being a pen tester to security research, or even taking more like leadership roles. And so all these projects essentially are a reflection of what I was doing at that period of time.
Cool. So you first came on my radar from GNU Citizen when you wrote a Attack API. So how has that progressed into PownJS and WebSecurify today?
Mm-hmm. Yeah, so GNU Citizen, I started this blog when I was a pen tester. And so I really needed a forum to essentially talk about security, discuss topics. I mean, what I had in my mind. GNU Citizen actually turned out to be like a small success at that point. So I'm really proud of the blog and all the people who contributed to it. And so eventually, after I was done with this and I moved on to other things, I mean, I'm not done with the project. I still want to blog. I don't find that much time anymore, really, to do this. But, I moved on to doing some other things. And then WebSecurify was born, which initially was like an open source security scanner. And that turned into a business. And from there, what happened was that we've created a different product called SecApps. And SecApps is kind of like, if I can describe it in a one sentence in a very, very simple way, I say it's kind of like the AWS for security tools and services. And because there was so much technology, so many things that we were doing internally, I thought the time was right to start kind of like open sourcing some of this stuff and put them online, put them into other people's hands. And the intention here is not just to, just do good. This was a big part of it, but also sort of like to learn from it, to learn from the experience, to see how the community acts, to be completely transparent. Some of the open source work that I've done in the past, they were not very successful, and I always find that running a successful open source project is pretty difficult. So the people who actually succeeded in doing it, big kudos to them.
So can you, what kind of functionality does SecApps provide?
Well, it's a collection of security tools and services, to put it mildly. So there are some there are some manual tools, the traditional stuff you'll find in web application security tools, like you have a proxy, you have like repeaters or fuzzers. You have tools that will help you work with like Swaggers, files and APIs, encoders and so on. Even tools to actually help you analyze pickup files, and all this stuff basically run straight off your browser. One thing that is very different from other tools is that we are leveraging the browser itself So, for example, you do need to install an extension in your browser for us to be able to do that. But every time you execute this request or these tests, they run from your browser. So they're not utilizing our own service or anything like this. So this is kind of unique for us.
What's the advantage of that of using as opposed to just proxying to something like Burp?
Well, we don't need to install anything. I don't need to install any tools, any specific tools on my computer. I don't need to install a proxy. I just need to go to a website, and as long as you have this extension installed, which is approved on the Web Store and the Mozilla Firefox Store, you could just start hacking right off from there. I mean, for me, this is my style of doing things. Sometimes you're curious, you want to test something very quick. I find the whole setup. I mean, these days, for example, Burp is slightly better, because it comes with its own browser, so it's sort of like easy to get started. But in the past, every time you need to do something, you need to start a new session, you start new browser, new instance of a browser, proxy stuff through it. It was a lot of setup, especially when you want to test something quick.
A lot of bounty hunters need to focus on automating their testing to find bugs. How does PownJS help them? How could PownJS help them find more bugs in an automated fashion?
So PownJS utilizes the vast JavaScript ecosystem to build new tools. So it's a very good platform for experimenting with technologies. And if you see, if you go on the github.com/PownJS, you'll see there's a lot of projects in there. Underneath, what PownJS really is it's not a framework. It's not like Metasploit or something like this. So there's no like a standard way of orchestrating this stuff. I would say it's just a collection of libraries, but these libraries can sort of like speak to each other in a very consistent way. Every module is essentially, it's a command line tool, which can be used either as part of Pown, or you can completely run it independently if that's what you want. And so, orchestrating all these tools is done by shell scripting. However, PownJS also has some additional features like its own scripting engine, which resembles Bash, and some other tools that actually essentially help you put together like a repeatable workflow.
So can we go through some of the functionality? Like Pown has a proxy. So is that how is that? You need an external browser to use the proxy, or what's the use case that you would use Pown proxy as opposed to like Zap or Burp?
So because it's not a framework, it allows you to sort of like pick the best tool for the job. So let me give you an example. So traditionally, you would use something like a proxy, like Burp or Zap. But on top of the proxy, we also have another tool, which is called CDB, just like acronym for the 3 letters, which stands for Chrome Debug Protocol. And this gives you like a proxy-like functionalities without having a proxy. This is using the Chrome Debug Protocol that is available in Chrome and Firefox to interface directly with the browser, what the browser is doing. So for example, if you want, to test some application that specifically is available over, HTTP3, I don't know any proxy that currently supports this. But Pown can do it because we're not operating at such a low level. We actually, we're not operating at the TCP level. We operate at the debug level in the browser itself, so we can actually see all the requests coming in and out, and then we can intercept them. So it gives you like a proxy-like functionality without the need to install a proxy. And this is a separate tool, but there is a lot of commonality between these tools. So they share a lot of common components. So for example, in the Pown proxy, you have like an ncurses interface, which allows you to edit stuff. And the same ncurses interface also is available in this other tool. So this is kind of like the shared stuff between all these tools. And the sharing happens as by the means of modules. You just create like a new JavaScript module, import the dependency, and through composition, you can just build new tools.
So there are a couple of modules, let's say Pown Leaks. What does that one do? So
Pown Leaks is essentially an attempt to build like a really, really good database for finding secrets, like AWS keys, some interesting URLs, passwords, and so on and so forth. So there's a lot of tools out there that do that sort of thing. For example, Git Leaks is one of them. This is one of my favorite. But Pown Leaks also has is trying to really get to the point where, what it finds is actually really, really good and filter out, all the false positives and things like that. And so we just started actually doing some machine learning that kind of introduced this component to the whole process as well. So in Leaks, you'll find a tool that essentially helps you find leaks, whether this is in files or in URLs or whatever you want. It has a database which can be easily extended. and also has like an extensive testing suite. So actually you can test whether these leaks are working. And then we just started working now on something that help us filter the results. And again, this is the component that is still being worked on, but essentially using something like machine learning.
What's the syntax like if you want to search for, let's say, GitHub secrets, or how would you run? Do you like pwn leaks, and then what's the syntax?
Oh yeah, so if you want to scan like a single URL, you're gonna run something like pound leaks and then HTTPS column / whatever you want. But let's say if you wanna scan, I don't know, thousands of URLs for different leaks, which is something common. And let's say you already have the list of URLs, maybe you extract those from some proxy logs, or maybe you use URLs from the web archive and some other sources like this. You can just pipe them through the tool, and the tool will fetch all the requests and will run the leak scanning engine.
So which essentially it's sending like a GET request to the URL and then just parsing the response?
Yeah, but this is only one of the possible interfaces for this specific tool. So for example, if I want to, and again, this tool is kind of like solving like a small immediate need. The idea behind Pwn is because it's made from this sort of reusable modules. The whole idea is that this modules needs to exist without Pwn itself. So that's what I am saying. It's not a framework per se. I know it's also pretty lightweight. So for example, if I want to build some different tool that is based on the Pwn leak functionality, I just simply need to import that into my tool. And that brings in like a very lightweight dependencies with it. It doesn't bring all the other heavy stuff that all exists with Pwn. And so, for example, if I want to build some other tool, one good example I can give you is that in Pwn, there is a tool called Pwn Git. And under Git, there is a command for finding leaks as well. The difference between this tool and Pwn leaks is that Pwn Git utilizes the leaks database and the leak scanning engine, all this stuff. But basically, when it scans, it runs through all the commit histories, which is a very different, it's very different from, for example, what you're going to do if you scan, I don't know, files or URLs, because the method of scanning is slightly different. You have to walk the Git tree, and then for every single commit, you need to find all the leaks and then figure out whether the stuff that you have found is something that is seen before and so on. So, through composition of libraries, essentially you can create new tools, and, Pwn is expanding in that regard.
Very nice. So I'm not sure if I quite understand. So leaks, it has a list of tokens or strings that it's searching for, right? So if you want to find AWS token string, so it has like a regular expression of what that would look like, and then it's scanning the results for that.
Yeah, the database essentially is a combination of regular expressions. Also, it has other capabilities, like, for example, calculating the entropy of the string, because sometimes, again, you might get like a false positive. So you could say, you can write like a simple regular expression that says, okay, find me everything that is prefixed by password equal. Obviously, that's going to give you a lot of results, and some of these results will be not good. So in that case, you might actually filter this result by saying, okay, I'm interested only in strings that has an entropy of 20, which means that it's random enough to be an actual password, but not too random, because you don't want to filter out like super weak passwords too, So the database is effectively a collection of these regular expressions, entropies, metrics, and other things like that. And then the leak scanning engine is essentially an asynchronous mechanism that allows us to search through a lot of data as quick as Node.js allows you to do. But Node.js actually is pretty good for IO stuff. So it's relatively quick.
Can you query the database after you have results? Can you query the database directly, or do you use Pwn to do that?
Oh yeah, the database is local. It's something that you essentially ship with the tool. But if you want to build your own database on top of that, that's also possible. So you're not restricted in terms of like what databases you want to use. But because you mentioned databases, this is another use case that, again, there's no specific tool for this, but it will be relatively easy to do. So imagine that you want to create a tool that you want to scan, I don't know, a MySQL database for like weird strings like that. Well, you can do it. We can do it with Pwn leaks, because the Pwn leak has the scanning engine and it has the database of leaks, of common leaks. All you need to do is simply write this orchestration layer, essentially this additional tool that will be able will give you the ability to query the database on which you apply the scanning engine. And so you can extend this for everything. You can eventually scan, I don't know, S3 file, like S3 buckets or whatever you want.
So what does the Recon module do?
So Recon is, I don't know if you're familiar with tools like Maltigo. So I've been a fan of this tool for quite a while, and I wanted to create my own tool. So I made a tool. It's called Recon, and it's available in SecApps, and it works pretty much in a similar way to Maltigo. You have like a essentially graph representation. You have nodes connected by edges, and you can run transforms on them. And so originally this was part of SecApps, and it was working really, really well. And I thought, okay, how about we take out the core, basically the graph part of it, and essentially put it as an independent tool. And so there's already a lot of reconnaissance tools out there. But one thing that I notice about them is that they all keep the data into sort of like a flat list, like on a 2D representation. Essentially have like a list of stuff. Let's say if I run some domain name reconnaissance, then it will give me a list of subdomains, but it doesn't give me any other context, how the subdomains were found, why they're there, and how they link to some other stuff. This is something that is left to the researcher or the pen tester to figure out. And so what Recon does is essentially it allows it to perform all these operations, but also it kind of like links all the information into a graph, graph representation. I've got some tools that can help you visualize the graph, so you can actually see it with your eyes. And some of these graphs are very pretty, although they're too complicated, I think, for us to comprehend. But the whole idea is that every single piece of information that you find through the reconnaissance process is somehow linked to other pieces of information, and that gives you the ability to query that information in a very different ways, and also understand how this information was gathered. So just to give you an example, let's say, you can do all kinds of complicated workflows, and we use these workflows in SecApps. I'll give you one example. Let's say I want to perform the following reconnaissance process. Let's say I have a target organization, so I don't know, target.com, and I want to find all the people maybe who work for target.com. Maybe one thing I'll do first is find what public keys are available public PG keys are available in this whatever the name of the MIT server was. And so from there, let's say I find, okay, these are the keys. From there, I'm going to extract all the emails. From there, maybe I'll figure out whether the first part of the email looks like a nickname, and maybe I'll take the nickname and then I'll try scanning, for example, all these social networks to find out, if there's accounts matching that nickname. And from there, maybe I'll find all the GitHub projects because one of the social accounts is on the GitHub. And then that way I can discover pretty much all the Git repositories that somehow lead to these people who lead ultimately to the target. So this kind of like a complicated reconnaissance process, it's super easy to automate with Recon.
And all that entire process that you just mentioned now can be done via the tool?
Yeah, I mean, the tool can do pretty much all this stuff. It has like standard transforms that are part of the tool. So it has capability to query GitHub, DNS enumeration, links, social media profiles, like essentially everything you can think of. In addition to that, you can extend the tool with your own transforms. You can run like your own custom scripts, or you can create like a transform server, which is fairly straightforward, like a web API. And there's some reasons why you might want to do this, But yeah, it will support pretty much search engines like Spice. It will support search engines like Shodan. So if you have keys and things like that, you can just incorporate all this stuff in there. And it has even features where you can automatically identify the data. So you don't necessarily need to be very specific, what you want to do. So, there's one transformer called auto, and just say like, okay, I've got a domain, just auto that,
And then what does it find in auto?
In auto, it will be like run pretty much everything that it thinks is relevant for this specific node, So, I mean, when you construct the transforms, you can also say, okay, how noisy the transform is, because obviously if the transform is too noisy, you probably don't want to run it. And in auto, like what Recon will do is basically, okay, take the list of all potential paths and effectively run all the transforms on that specific node, and then come up with a whole lot of data. This is how usually we'll start. In a reconnaissance process, you have like a very small amount of data. Let's say you have only a domain name or a brand name. And then you say, okay, I want auto everything, just find me anything that you can find by yourself automatically. And that's gonna bring in a lot of data. And then once you have this data, now you can do more specific stuff. Now you can say, okay, now I've got this data. I wanted this data to be processed in a certain way. And you can kind of like orchestrate everything in Recon.
How does the tool handle not getting locked out by pounding external APIs?
Well, this is something that you need to figure out yourself. So at SecApps, we have figured this out, how to do it properly. There's no magic bullet. That's the thing. So you need to have proxy servers. You have to have infrastructure in place. There's no way you can cheat this, unfortunately.
Yes, come across that in lots of other tools. So what does the Buster functionality do?
So Buster is something that helps you brute force things very quick. So whether this is directories or maybe emails. So there's two functionalities in there. One of them is emails. The other one is directories, like web directories. But this can be achieved also with other tools. So as I said, like some of these modules, they're kind of like they follow the Unix philosophy. Like do one thing but do it very well. Some of these modules may contain like subcommands. But they might have like a subcommands as well. But the thing is that they're kind of like there's a common theme around the module. So let me give you an example. So lately I've seen like some tools that started really well. I mean, I was in fact impressed. I was thinking like, man, this is great. And then over time, these tools start deviate because they try to do too many things. Eventually you get to a point where it's not a tool anymore. It's kind of like some, I don't know what it is. The problem is that you no longer can do the trivial cases in an easy way because you have all this like complexities in there. And so with Pown, you don't have that problem because the tool can be as simple as you want or as complicated as you want. So for example, Recon is fairly complicated because it uses this sort of like a graph representation underneath. So there's some complexities around that. But Buster is pretty simple tool. It just utilizes some of the asynchronous features and request sending features and like scheduling features of Pown. And these are like separate modules and essentially uses those to create the specific functionalities that it needs. And the two of them that currently supports brute forcing directories. Again, you can achieve this, by the way, with some other tools, more specifically like emails. So let's say I've got like a list of, I don't know, names, and I want to find out whether there are inboxes associated with those names. That's useful sometimes.
And that would require the external SMTP server to respond to like a verify command?
Yeah, it's very simple. It kind of like starts like a chat session with the server, and believe it or not, I mean, all kinds of servers will give you this information, including Gmail. Like if you use Gmail, they'll respond.
Yes. Now, what about the brute force the directories? So does it have its own built-in list of directories to look for, or can you supply external ones, or how does that work?
So there's another, again, like everything is like a separate tool, so you can get lost in them. But there's another tool called dictionaries or dict. And there in the dictionaries, it kind of like it comes up with the list of readily available dictionaries that people use. So it's a small collection, and you can download the dictionaries, you can search them, you can filter them. So the tool essentially is just responsible to do this, like managing dictionaries. So if I say, okay, I want, obviously, if you know what dictionary you need, you know how to get it. But let's say I'm thinking like, okay, I want a dictionary of usernames, right? So I will say like, okay, the name that I'm searching for is just user, star or something like this, and it will just figure out, okay, these are all the dictionaries that has to do with users, and then you can say, okay, download all of them, and you will standard out pretty much the output of the dictionaries. Then you can use that output and pipe it into some other tool and effectively put this like a workflow together in a very simple, trivial way. So you don't need to know anything about dictionaries. You don't need to know like where to find them. You don't even need to care, for example, if the tool will incorporate new dictionaries in the future.
Okay, and if I want to import my own dictionary, is that just a word list, or does it need a certain format?
Well, in this case, probably it's not a very good use case because this one is designed to. I mean, most of the tools will support some kind of input as a dictionary. So if you have your own dictionary, you can use it in the tools. This one specifically manages like known dictionaries like FuzzDB and things like that. There's quite a few of them.
Like if I want to use like sec lists.
Yeah, a sec list is part of it. So And so we're not actually incorporating these dictionaries because they're obviously maintained by other people. We don't incorporate them inside the tool. What the tool does is simply managing access to them. So, for example, if I want to fetch the latest list from sec lists, then I can do it via the tool. I don't need to, and I can do it in a very generic way. I don't need to be super specific. I don't need to say like specifically I want the sec list, like a collection. I can be very fuzzy about what I want. I can say like, I don't know, XSS underscore attacks, because I know from memory that there is such a file somewhere in that collection of dictionaries, and it will just download that one.
Nice. Now, what's the advantage of using the built-in scripting engine as opposed to using something like Bash or Python?
So you could do it. You could do it with Bash for sure. There's one small use case where I think it's better to use the scripting engine. The scripting engine is sort of like a subset of Bash, without the if statements and all this stuff. So, but it looks like you're executing commands, and I would say that if you keep your scripts very minimal, you can easily use them for Bash. Like you can use them in Bash or in a Pound script interchangeably. Both of them are fine. But there are some situations where you might not want to use Bash, and that is, let's say, Recon. Now, Recon again generates graph. The way you operate on that graph is through commands. So you can say, okay, I want to add some node. But when you run the tool doesn't know where the graph is. So you say, okay, read the graph from this file, right? And then once the tool exits, you need to say, okay, write the new graph into a different file, right? And so if you orchestrate this with Bash, you need to basically do this all the time. With Pound script, everything is within the context of the JavaScript engine. So what that means is that once I load up the graph, it just stays in memory. And then all subsequent commands effectively operate on the exact same piece of data. I don't need to do anything special about like it kind of like the equivalent of this would be something like PowerShell. You kind of like manipulate objects at that point. You're not working with text.
Very nice. So say you're a bounty hunter in the recon phase, what workflow do you recommend to learn about your target?
It depends what you want to do. Different people have different interests and different way of doing things. So, normally I'll start with Recon. So in SecApps, we have a tool called Scout, and that's what it does. Basically, it does like a very deep sort of passive analysis of the target. And that gives you a lot of data, domains, URLs, email addresses, secrets, screenshots, like pretty much everything that you can think of. And then once you collect all this data, this is my workflow. Once you collect all this data, then you need to make sense of it. This is when you kind of like understand what the target is, what kind of stuff they have, whether you're missing some things in them. But the beauty of starting from a graph representation is that I don't need to repeat the same job like 50 times per day, to get the desired outcome. I've seen this far too often from people tweeting stuff online. They're like, okay, here's a new one-liner that basically takes a bunch of domains, then pipes them into another tool. And so on, which is great. It sounds great and it looks great, except that every time you do it, you're just saving the output, but you're not saving all the other interesting stuff potentially happen around you. Like for example, if I'm looking for one specific vulnerability and I'm just searching for that specific element, I will miss potentially another vulnerability that I wasn't looking for, and I just blasted off like 20,000 requests. And one of those requests probably had like an interesting error that wasn't highlighted to me. This is a shame because you've missed the bug. Sometimes this stuff happen actually just right there. It just you have like an opportunity. It had happened and it will never happen again. And so the whole point of Recon is to capture that data somewhere and capture it in such a way that I can go back to it and I can learn what happened. If you, for example, again, this sort of like a trivial example. Obviously, if you pipe this into, if you install like a transparent proxy, if you install some kind of like attack proxy in between, you'll be able to collect that data as well. So that's one way of doing it. But yeah, Recon is very good at putting context around your data. So I can always find out, okay, here's an interesting domain. Where did I find that domain? Who owns it? How did I get there? Like what other information I can get from it? Was it linked to somewhere else before that, and so on. And so it's very, very useful.
It's interesting having the visual element to start with gives you much more context than just automating step by step, give me all the domains, and then just having a list of domains and then recursively scanning each of those.
Yeah, and it's very natural for us humans. You've seen probably in like some of this like a CSI, like people plotting like you have like a board, with strings, like plotting exactly what's the connections between the different people and things like that. This is a very natural way for us to perceive data and complexity of data.
Definitely. And once you can wrap your head around understanding, like especially when you have like too many nodes, then the graphs tend to get very complex and confusing.
It gets you start getting like a perception of depth, when using graphs, because a graph is not just a collection of things, it's a connection of things with relationships, and those relationships can be represented in a very different way. For example, let's say I've got a node that there's all kinds of other nodes that are linked to it, and what I want to do is that every time there is some other node linking to that node, so it has an edge to that node, I want to make it bigger. So obviously when I put that graph in front of me, I'll see like a much bigger bubble. So I know this thing is important right there visually without the need to do any queries or anything like that to calculate the size. This contextual information is in front of your eyes. So for example, let's say I've just did a lot of scanning and I've collected a lot of requests, and then all of them return maybe some server headers and things like that. I mean, this is again like a trivial example that I can give. And the server happens to be, I don't know, Nginx. You'll see Nginx is a much bigger bubble, compared to all the other bubbles. Because without the need to query that information, that this company is using Nginx predominantly. I mean, it's no surprise there, like everybody does, but that's the kind of contextual information you can get out of a graph without the need to do any additional work.
Cool. All right. I want to wrap things up with just an understanding. How did you mentioned you got into security around age 10. Can you tell us a bit how you got into InfoSec?
I don't remember if I was age 10, but I remember when I was young, and this is a true story. I was trying to learn Pascal, and I didn't have a computer, and some of the first programs that I wrote were on a piece of paper. And I remember I was giving this piece of paper to my mom to check. But the first piece of program I wrote was like a password entry program. But like for me, the pivotal moment, and I don't know if this is true for other people my age, but for me, the pivotal moment was when I saw hackers for the first time. As funny as it sounds, I mean, this is when I was like blown away. I know this very quickly. I started researching, okay, what sort of computers they were using, that sort of stuff. I just like draw myself into the scene, like reading online insights and things like that. So it was, it was a very good time to start security because it was quite fun.
And what was your attraction to JavaScript and Node?
I don't know. It somehow stuck. I mean, I have experience with quite a few programming languages.
You haven't pivoted to Go?
No, I've done Go. I've got Go projects. I've done Go. I've done Swift. I love Objective-C. I think Objective-C is such an underappreciated language. C and C++. I mean, this is something that I feel quite comfortable with, and I've done a lot of Python as well. So and Perl. So I've done all these other languages. One thing that JavaScript, and I don't know where exactly it started. I suppose when I was involved more in like web security stuff, this is where I had to use JavaScript more. But I mean, today I think that JavaScript has like one of the biggest ecosystems, programming ecosystems in the world. Like every time I need to do something, I know that somebody has written a package that solves this problem in some way. And this is a lot of power, because you can just. Now, there's some problems with this approach. Obviously, security and stability issues, we know about them. But in terms of experimentation, I think JavaScript is just unbeatable. And in fact, I don't understand why there's not more security researchers using JavaScript rather than Python, because there's so much more in JavaScript you can do. And actually, virtually every computer is shipped with some kind of JavaScript interpreter, whether this is inside your browser or actually it's been part of the OS. Like, for example, in Windows, you have JScript, which is part of the kind of like standard package in OS. So you can run like a dialect of JavaScript pretty much right there and then. You don't need to install anything. And also, not many people know, but actually even like graphic drivers, like GPU drivers and stuff like that. Actually, some of them ship with JavaScript interpreters and things like that. So, every computer in the world can execute JavaScript without the need to install anything else, So it's kind of universal at this point, I think.
All right, PDP, thanks so much for coming on the show.
Thank you. Thank you, Josh.
All right, that's it for this week. If you have any comments or questions, then tweet at me at Jamoose. And if you got value from this episode, then please share it with a friend. See y'all next week.